When it rains, there are a bunch of water droplets in the surrounding air. You can tell just by putting a straw in a cup of water that water refracts/bends light. So we can assume that when light travels through the air after it has rained, the light will refract due to the light traveling through the rain droplets of water. It makes sense how the light will refract. However, how do we see that spectrum of colors rather than the ordinary white light? Well, the direction that the light travels isn't the only thing that changes. When light passes through a medium, like water, the speed that the light is traveling also changes. On a side note, we need to discuss the differences in colors of light. The difference between the colors of light, Roy G. Biv, is the wavelength that light travels. Scientists have come to the conclusion that light with different wavelengths travel at different speeds in a medium. Therefore, dispersion occurs when white light travels through a raindrop, showing all the different colors of light because of the different colors of light have different wavelengths, and the change in speed of light through a medium depends on the wavelengths of light.
Alright, so I'm using a hose that is on the setting of mist, and when I spray it in the air and the water droplets connect with the sun, it creates a rainbow like this.
We know white light is made out of a bunch of different colors of light, but what are those colors of light made out of? We traditionally know light as a wave, however, Albert Einstein discovered that light is also made out of a bunch of bundles or packets of light waves, which we call photons. The discovery of the wave-particle duality spawned the field of quantum physics. Light never acts as both a wave and a particle, photon, at the same time. Depending on the situation, light will behave as waves or a bunch of particles, but never both. White light is made up of all of the wavelengths of the visible spectrum at the same intensity, and that's why you see white light like this. We know sound waves travel through a medium of air, but what about light? The scientist James Clerk Maxwell combined the phenomena of electricity and magnetism and discovered in the process the medium of which light propagates through. Maxwell discovered that light is oscillations in the magnetic and electric fields. Light is, in general, fluctuations in both of these fields. Light is self-propagating, meaning that it travels without the need of any exterior force. When there is a fluctuation in the magnetic field, that causes a fluctuation in the electric field, which then causes another fluctuation in the magnetic field. And soon, these oscillating fluctuations causes light to travel at the constant speed, which is c, and gives light the energy it has. In the United States, Hawaii is one of the best places to see rainbows. Hawaii is often referred to as the Rainbow State. Out of all of Hawaii's islands, Kau is the rainiest of them all, so it makes sense that rainbows are plentiful in this region. Another place to see rainbows near the United States is the Niagara Falls. Tourists often see multiple rainbows appear at the same time through the fall's never-ending mist. Most rainbows we see will be a primary rainbow, whereby the color red can be seen on the outer edge through to violet on the inner edge. The sky within a primary rainbow is brighter than the sky outside of the arc. This is due to the fact that millions of droplets needed to make a rainbow are spherical and overlap to create white light. At the edge, however, these colored discs don't overlap, so display their individual colors producing the rainbow arc.